Another Newton's Law problem example. We're going to do number 28. Number 28 on page 106. And it says, a person pushes a 14.5 kilogram lawnmower at constant speed with a force of 88 newtons directed along a handle, which is at an angle of 45 degrees to the horizontal. And they give you a picture. First it says draw the free body diagram, calculate the horizontal retarding force on the mower, the normal force exerted vertically upward on the mower by the ground, and the force the person must exert on the lawnmower to accelerate it from rest to 1.5 meters per second in 2.5 seconds, assuming the same retarding force. Okay, so the first thing we need to do is draw a diagram. They gave us the mass of 14.5 kilograms. We know it's being pulled down by gravity, mg. We have a normal force from the ground. There's a frictional force, and there's also the force of the person pushing on the lawnmower, which is 88 newtons directed at 45 degrees to the horizontal. So that's like this. So that's our diagram. Okay, we can find the weight. We multiply mass times 9.8. So 14.5 times 9.8 gives me 142.1. That's the weight. Okay, I want to break up the force of 88 newtons into its components. So we'll do 88 cosine and 88 sine of 45 to do that. Here's 88 cosine of 45. That's horizontal. And 88 sine of 45. Obviously, since it's 45 degrees, the two components are the same. Plug them into the calculator, you get 62.2 newtons for each one. Now, once I get those components, we can forget about the 88 newtons. We're not going to use it anymore. We're just going to use the components instead. I know that there's friction because it said that it's moving at a constant speed. And if you're pushing something and it's moving at a constant speed, then there must be friction. So we'll go to the y direction and the x direction using Newton's second law. MA in the x direction equals sum of the forces in the x direction. MA in the y direction equals sum of the forces in the y direction. I'm going to work with the y direction first. The acceleration in the y direction is 0 because the lawnmower is not flying through the air and it's not going through the ground, so it's 0. There are three forces acting in the y direction. We have N going up, we have 62.2 going down, and we have 142.1 going down. So we can solve for N, and you get 204.1 newtons for the normal force. And we'll go to the x direction. In the x direction, we have two forces. Forces are 62.2 newtons and friction in opposite directions. But the acceleration is 0 because it says it's moving at a constant speed. So then we prove, okay, the frictional force equals 62.2 newtons. And that's the horizontal retarding force that they were asking about, and it's friction. Part D says, calculate the force the person must exert on the lawnmower to accelerate it from rest to 1.5 meters per second in 2.5 seconds. So it starts at rest, it gets up to 1.5 meters per second, and the time that takes is 2.5 seconds. So we can use that information to find an acceleration. It's 1.5 meters per second minus 0 over 2.5 seconds. And we get 0.6 meters per second squared. Now what we're going to do with that is plug it back into our x equation, now that there is an acceleration, and solve for the applied force, assuming that the frictional force stays the same. So MAX equals, we have some new applied force, I'm going to call F applied, minus 62.2 newtons. The mass is 14.5 kilograms. The acceleration is 0.6 meters per second squared equals force applied minus 62.2 newtons, and I'm going to solve this for force applied. If I do that, I get 70.7 newtons. Now, the only problem with that is that's actually the horizontal component of the applied force. It's not actually how hard the person is pushing, because they're pushing at an angle at 45 degrees. So you can imagine if they're pushing along the handle at 45 degrees and the horizontal is 70.7, the vertical must also be 70.7 because it's a 45-degree angle, and you can't help that because of the handle. We have to find the hypotenuse. So we use the Pythagorean theorem, 70.7 squared plus 70.7 squared, and you get 100 squared. So the answer is 100 newtons.